everyone. Thank you so much for joining our lightning section today. I would like to give the floor to Gloria, one of NAIJA-JUG user group's admin. She has something for us. Thank you.
Hi, good evening, everyone. I'm so excited to have you all here. We'll just be playing light videos on celebrating our journey so far, since we're in the season of anniversary. So while we wait for others to join, please join us on how we started. Thank you. So please, can anyone see my screen?
Yes, Gloria, we can see your screen.
So please do confirm if you can hear the sound as well. Yeah.
No, we cannot yet.
Can you guys hear it?
No.
Okay, 1 second.
Can any other person hear the sound? Because I can't.
No, we can't.
Oh, sorry. Oh, did someone say they can't hear the sound?
Yes, we can hear the sound. Maybe you can just give us a voice over while the video is playing. So we move ahead.
All right, give me a sec. While I do this one, I can't see. Oh, shame. All right. All right. Apologies about that. Let me share my screen again. Oh, thank you.
Sorry, Gloria, we can't hear you. Yeah, I think Gloria's network is bad, but what you are seeing on the screen currently are the people that we have been privileged to learn from them. Some of them has presented during our monthly sections, our lightning sections, and our boot camp programs. So we are celebrating our 1 year anniversary as NAIJA-JUG user group, and this is our way of celebrating ourselves, understanding how far we've come. We've had a lot of bright minds come to this platform to share their experiences with us. And we are saying thank you to all of them, and we are appreciating all the NAIJA-JUG user groups admin for seeing, giving us the opportunity to make this happen for 1 year. Is not easy. Every Tuesday of every week, 4 weeks in a month, every month for the past 12 months. So this is not an easy feat, and we are proud of ourselves and how far we've come. Yeah. Yeah, we also had the DSA sections. We used to have DSA sections previously. So the flyers in red are for our DSA sections. This is just an impromptu voiceover. I hope you understand what's going on, what you're seeing on your screen. Thank you, thank you, thank you, thank you to everyone that have been joining our sections for the past 1 year. We say thank you. You all are the real MVPs. And this is us saying cheers to the next 365 days. Thank you. Thank you, Gloria. Thank you, everyone. Yeah. So we'll move into our sections properly. Hi everyone, please if you can hear me, react with your favorite emoji as a way of celebrating NAIJA-JUG user group. We are 1 year and we are so excited. Thank you, thank you. So my name is Rosemary Urokonena. I'm a Java software backend engineer and I'll be your anchor for today's lightning section. So for those of us joining us for the first time, NAIJA-JUG user group is a community-driven platform that is dedicated to bringing together Java developers and those that have passions for tech across Nigeria and even beyond. Our mission is basically is centered around learning, collaboration, and professional growth within the Java ecosystem in Nigeria, to be precise. In Nigeria, and we do this through our monthly sections, our lightning sections, our DSA sections, and our bootcamp as well. And we aim to build a strong space where developers, not just Java developers, but those that are new into the industry, to connect, to learn new things, the new technology and trends, and also to discuss opportunities, job opportunities and other opportunities in the industry and the Java ecosystem. So during the course of our section, my colleagues will be dropping our links, our social media links, our LinkedIn, WhatsApp, YouTube. Please do well to join our community so you don't miss out on any of our program. Please, if at any point you cannot hear me, please call my attention so that I will adjust. Yeah, so moving on to today's section, we are excited for our host today, Oddy Bassey, who is a software engineer at Turing. Like Turing, I only used to hear about it or see it on LinkedIn, but I'm super excited to be hearing from someone that actually works with them. So it's a real life something. It's not just something I see online. Yeah, I'm super excited. And before we proceed, I would also like to give a shout out to our one of our sponsors, the JetBrains, for their generous support in making our community sections possible. Thank you all for joining us today, and I will be handing over the mic to Oddy Bassey. Thank you. Join me in welcoming him with your favorite emojis. Hi, Oddy.
Hello, guys. It's a pleasure being here. I think I joined in one of your sessions much earlier this year and last year as well. So I think the one particularly where that famous Java developer, forgotten his name, but I saw him on your flyer. So yeah, it was really nice to be here. And I'm here again to give my first presentation. So yeah, just so you know, this will be my first presentation on any tech platform. So yeah, the host talked about Turing. So I'll just tell you guys, in case most of you don't know what company Turing is. So Turing is basically, it's a technology company that helps outsource very good software developers to different organizations. Recently, they are more focused on AI. They are more focused in AI, especially around helping frontier companies like Google, Microsoft, and the likes train their models or their LLMs and get them very good and efficient. So I'm actually an AI engineer there, more like Java, Python, LLM engineer. Yeah. Okay. So I have quite an interesting presentation for you guys today, and it's titled types. Hold on, let me just get to the start of it. Okay. Yeah, so it's titled Java meets generative AI, building a type-safe AI code reviewer with SpringAI. Okay, let me just share my screen so that you guys see what I'm presenting. Give me a second, guys. Yeah, so you can just confirm when you can see my screen.
Yeah, we can see your screen.
Okay. I will just provide the link of the repository on the call chat so that anybody that would like to get it can just go get it there. Okay. Second, please. Okay. So everything is in there, including the slide I'm looking at right now. So if you want to get the slide, it's just a simple HTML file in docs folder. So there are like 3 slides. There are 3 files there. So the first one is the presentation slide, Java meets generative AI. The second one is basically a run through on how everything in the code basically works. It's a brief one. Then for anybody that may need detailed information, the third one is inside the AI code reviewer. So it gives you detailed information as to how the code is set up, the classes and all that. But it's not a difficult code base to understand. It's quite simple and it's an extract of something I'm building. So what is this really about? So basically what this is it's basically a simple Java application that a simple command line Java application that shows us the relevance of type safety when working with AI in Java. As you would know, there are the Java community or the people developing Java and Spring Boot. They've been able to provide us different libraries that enable us to work with any frontier AI model, right? So with that library, we are able to harness AI functionality and capabilities in our applications. And this is quite relevant for companies that companies using Java. And as you know, there are lots of big companies using Java for their systems, or I would say critical systems. So if they wanted to integrate AI, how would they do that? what are the bottlenecks they could face, things that have been set in place to help them also handle those bottlenecks. So one of them is type safety, which is really important. So a brief run through about what this application is. It's basically a command line program that reads a unified diff, asks a language model to review it, and then gets the answer back as a Java object rather than as text. It exits non-zero when the review contains a blocker, which makes it usable as a build gate. So it's a Spring Boot application, but not a web one. No controller, no endpoint, no ports. It just boots, runs one command, prints, exits, and that's basically it. So this kind of things are something you could integrate in your CI, or let's say you are building an application that for instance, I'll give you an example. So if you're building, let's say, an AI tool that is going to enable you manage your code base and deploy your software without you having to do that manually, this is something you can leverage as well. Okay, so how the reviewer works. So basically, what it does, it reads a unified diff, asks a language model to review it, and then gets the answer back as a Java object. The whole argument fits in one line instead of a content, which hands back a string. So here we're basically demonstrating like providing a code diff to the AI and then asking it to review it. One of the demonstrations shows us how we receive the review response from the AI as a single string, and then some other demonstration shows us how we receive it in a typed object. So there are multiple paths the diff can take. So basically, every mode of the program is a slice of this sequence. The framework does the middle. The decisions about whether to trust the answer are just basically ordinary Java, right? So we load the diff, we number every line on the diff, we build the prompt, which is mostly like the system message, the diff, and the JSON schema derived from the record. Then we call the model through the official OpenAI Java SDK, and then we bind the reply. So we are binding the reply into a class called the review report, and then we validate the object, and then we ground it. And lastly, we print and set the exit code. So there are lots of this. The document here is really explanatory. If you go through it in detail, you have a better sense of understanding as to what's going on. But I'll just run through it. So in the application, we have the application is structured. This basically tells us about the structure of the application. So we have the domain package. These are the packages in the app. So we have the domain package, contains 5 records, enums that describe the answer we want, precisely enough for SpringAI to turn them into JSON schema on the way out and back into Java objects on the way in. We have the review package, 6 classes that do the actual work, of which 3 talk to the model and 3 decide whether to believe what it is, what it said actually. Then we have the demo, 2 small classes that stand in for the real model with a response captured earlier. So the entire application runs with no network and no API key. So peradventure, let's say you don't have an OpenAI API key, or let's say you are out of credits, you can still run the application. Basically, what it will do is it will return stubs for you, but basically the idea is just to illustrate how everything works. So you necessarily do not need a key, but if you do, that's fine. So you see it work with a live model, but if you don't, it's still fine. You can still run it. Then the root package, the resources contains the configuration, sample diffs being reviewed, and the recorded replies that replay mode serves. So the replay mode, basically, like I said, if you don't have a key, what you're going to be getting when you run it is replies that have been saved. So it will just send that to you instead of trying to reach out to the live model. And then we have the test package. One particular class that's most important in this presentation is demo is the code reviewer class. So basically what this is, everything else is scaffolding around this class. It has two public methods, and the difference between them is the difference between having types and trusting the answer. So by the time I go into the class, you're going to see what I'm talking about there, what it is built with. So the constructor takes a chat client builder, which Spring Boot auto-configures the moment the OpenAI starter is on the class path, and a validator, normal Jackson validator. You guys are aware of that. Then it attaches a system prompt once at the construction, so every call inherits it. So that's what you can see here. So yeah, the system prompt is deliberately short and yada yada yada, you know, all that. But then what happens? What does it really do for the review? So here the review types only receives a diff as a string, receives the text, the user text, and then passes the diff, and then make the call, and then returns the gets the response as in the review report class. Okay. Another demonstration is around validation. So for the review validation, it uses this the same call wrapped in a loop that handles three outcomes. The first outcome is that it's bound and validated. It bound but broke a constraint, right? Such as confidence of 4.7. The violation messages are collected and handed back to the model. So the retry is informed rather than hopeful. Third one is it did not bind at all. And the class, so here, the class then asks whether retrying could possibly help. So what's happening here is when we provide a type for the model to bind the response to, if it successfully binds it, we get that response back. If it doesn't bind it, what's going to happen is we are going to evaluate, or we are going to check the error that's being thrown to know if the error is if it's an error that originates from the model being unable to correctly return the response structure that we asked it to return. So if that's the issue, we are going to retry the call again. But if it's something else outside of that, so let's say something that's not really tied to the model, something about maybe bad code you wrote or network issue and all, it will just fail gracefully. Yeah. So what is the grounding check? Basically, we are providing a diff, and in the diff we have what I've done there is I've put in multiple failure points where I expect that by the time the model reviews the code, it finds these particular issues there. So so basically we are looking at a particular issue in a particular line. So assuming we give the diff to the model, right, and the model evaluates that, the model is going to send back a response telling us, okay, I found this issue at this line, this issue here, this issue here. How do we know basically that what the model is telling us is correct, you know, based off diff? So this grounding check basically does that check for us, you know, to verify that, you know, what the model is actually saying is true. Okay. Yeah, so you can see the explanation here. Grounding is the answer to a simple question. Is this finding about the code that is actually in the diff? Yep. Okay, letting the model read the repository. Yeah, so you can just go through this and you get a better sense of, you know, what's happening here. This is the more detailed information about the code, about the entire application. So yeah, you guys can go through that. Okay, so now enough of the talk. Let's get straight to it. Like I said, what this talk is and what it's not. These are the things it's not: an introduction to language models, prompt engineering tricks, a claim that AI should review code instead of your team, slides of someone else's benchmark numbers. What it actually is one Spring Boot application built in front of you, a model's answer turned into a type your build can act on, the unglamorous parts, validation, hallucination, testing, cost, code you can clone tonight and run against your own diff. So when you guys get it, you can play with it. The interesting part of AI in Java is not the model, it is the type system. We all know that. We know that Java is strongly typed, and this is something that AI really benefits from as it's being integrated into Java. So a model that returns a string is a demo. A model that returns a record, you can validate, test, and gate a build on is a software. It's software rather. Every AI code review demo ends here. Paste a diff, ask a model to review it, read the answer out loud, applause. Yep. So we see how the code is being called. We make use of the chat library. We provide the prompts. This is a system prompt. Then we provide the diff, and then we make the call, and then we get the content. But here we're basically demonstrating when we make the call and expect a string content. How useful would that really be to us? It's not very useful. Although the review is good, but there's not much you can do with such response. Peradventure, let's say you wanted to get structured information as to, let's say, what the types of errors are that have been found and all that. It's not very useful. 4 things you cannot do with that string: fail the build when and only when there is a blocker. Count how many security findings this quarter. Post each finding as an inline comment on the right line of the PR. Write a test that asserts anything at all. These are things you definitely cannot do. As opposed to receiving the answer as a string, how else can we do that? We can do that by describing the answer we want in Java. Someone raising their hand. Yeah, go ahead. You're muted.
Lukman, your hands are up.
Okay, so I'll just get on because we have limited time here. So yeah, as opposed to receiving the answer as a string, how best can we, receive it? We definitely can do that with Java objects. So here we define a Java record called finding. And as you can see, we write out various properties of the record, like the file, the string, the file, which points to the file path, the line, which points to what line of the code has been identified. You can also see that we apply validation annotations here. This field must not be blank, and then JSON property description, to describe what the field is. Also, we have the severity, the category. These are definitely enums, I believe. The title, the explanation, the suggested suffix, and then we have the confidence level. If we go deep into the code, you can, take a look at all of this and definitely see it, which we are going to do. Or you know what? Let me just do that. So let's take a look at that. Okay. So yeah, so this is the finding. Yep. You can see everything that was there. So let's see what the category is. Yes, the category is an enum, correctness, security, concurrency, performance, style, testing. Take a look at the severity as well and see what is the severity. Blocker, is it a blocker? Is it a major issue? Is it minor? Is it NIT? So yeah, back to this. Same thing, it just reuses the same, just a few difference we are going to make to the initial code by basically what we do here. We just, before we use the string content, but now rather than do that, we are defining what the response type should be like. And we provide this class, review report class. So there we are telling the model that, you know what, this is the structure I want. Take it and provide your response in this structure. Review reports, JSON schema, and then review reports. Yeah. Okay, so now by the time we execute the command, we expect to see the model's response come as such. But you know what? Let me demo this first. Let me execute the code and show you what the model's response would be like when it returns the response as a string. So in order to demo the code, you can just look through have a look at the README. The README it documents everything about it, so everything about the application, and then you see instructions how to run. So you can just copy this. Yeah. So this is the first thing you need to copy. It sets your API key, and then it executes, it builds the application, and then it runs the shell script. So let's go back here. I've executed this command already. So I've set the API key already. So I will just I will not do that again. Instead, what I will do will just be to run to build the application and then run this. 1 second. So let's build the application. While that is building, let me get something else so that you guys see what is going to happen. Okay, yep. So we'll run this command. This is the one that asks the model to return the information as a string, or just basically gets the model's response as a string. So go back there and yep. Let's run that. Paste. Yep. Okay. So you may be wondering what is being executed in this script. So basically what's being executed in this script is this class, the review class, code reviewer. So let me just show you that. So the code reviewer, basically, so here you can see this is the review method. This is the one that reviews the code with with the specified structure that we want to get the response in. So this is basically what's going on, being executed there. Let me get back to that. So when we run this command, let's see what the model returns. So this is the first act. The answer is the string. So we're expecting that the model will respond with the string. So we're just waiting for the code to make the call to OpenAI and then return the response. Yeah, so as you can see, OpenAI has taken a look at the code. So you may be wondering, what code did you even look at? So let me show you the code. So if you come to resources, samples, right? So it's looking at the payment service diff. So this is just a diff of a code with bugs injected at different lines, certain kinds of bugs. So this is the code that's been sent to it. So let's see, what was this review? So it said number one, SQL injection in load account. Okay, let me find a load account here. Yep, you can see here, we've injected an SQL command in this method. So that's the first thing it points to. Right. So SQL injection. Number two, in-flight is not thread safe. Check, then act. So in-flight is not thread safe. Let's see. Where's in-flight? Yeah, so in-flight is not thread safe. Here we are using a map. So now, what is basically telling us is, let's say we have a method that debits information on an account, right? And let's say there are multiple threads, like the problem of people making concurrent requests in payment systems. So let's say you have multiple threads that make the same call, on the same data or on the same account. Those threads will definitely have access to this variable. And because they are an independent threads, it means they can modify this same record at the same time. And that creates a data consistency problem. So here, the model is already telling us that, rather than use just a map, it would be better to use a hash map. Use concurrent hash map and compute atomically, right? So you see, these are the things it points to. So it's giving you real life, it's more like a real life scenario, what the issues that you're facing in a live system, and how the system would respond. So you would definitely not want to push this kind of a thing to for instance, a banking system, because I'm sure lots of us here will lose all the money we've been working so hard for. Yeah, the third one, idempotency implementation is incomplete, unbounded memory growth in-flight. So where's the idempotency implementation? So, so it did a good job, finding all this, but now you see, it returns the response as a string. How relevant, how useful is this? Not very useful. I'm sure most of us here know that there's not much we can do with this on the system. Peradventure, if we actually wanted to take logs, or go back to fix this. But let's see how else we can get this data in a better form, right? So let me go here. So if you want to get the data in a better form, let's run this command, this one. Or you know what, let me run this one. Let's see how the data is going to be returned, or how the response will be returned. So yeah. And what does schema mean? So schema, it returns, JSON schema derived from the record. So here it returns the data as a JSON schema. Yeah, so JSON schema SpringAI derived from review reports. Yep. So it returns the response as a JSON schema. Let's get something even better. Can we get a type instead? And this type is basically the class we defined, review reports. So let's go here. Let's see. Okay, this is exactly the type we defined, and we can take a look at the object to confirm this. You can see here what type is this, a blocker. These are all blockers. Then this one's the major issue. What is the major issue? Insufficient funds check is incorrect. It points to the path and all that, the description, the fix, the verdict. So let's look at the object. If this response corresponds to that, code review. No, it's finding. So we have severity, category, title, explanation, suggested fix, confidence. The line and the file. So let's see. Yeah, so basically everything is here. You can all see these are individual objects. See the confidence here. Everything is here, as you guys can see. So yeah. So let's just go ahead and continue with the slides so we see how that progresses. Yep. So we can see that because we've been able to specify the structure of the data we want to be returned, the model is able to comply to that. And peradventure, if the model doesn't really comply, there are guards that help us through certain errors if the model does not really comply. So let's take a look at that. Let's see. Okay. So there is a method called review validated. If the model doesn't really comply to the structure that we want, what happens? do we just receive the response from the model that way, or do we throw an error and ask the model to, to throw an error and retry the request again? So let's just progress and we'll see what happens. Now the answer is the value. I believe we all saw that. A well-formed answer is not a true answer. So so here the idea is that the record proves the shape. It proves nothing about the content. So basically, all you know, all the record tells you is that, okay, this is the shape you wanted the response in. But does it really tell you if the content is valid? No, it doesn't. So you need to apply some other guard, to ensure this. So the model can hand you a perfectly valid finding, correct types, valid enum, non-blank strings about a line of code that does not exist. So we'll see how we go further to handle that. So here we implement, so we validate, then we try in model's own words. So basically this code validates. Do not retry blindly. Tell it exactly which rule it broke. Yep. So there's a code that helps the model, that helps us to catch the issue, catch where the model has gone wrong, and then we tell it exactly what rule it broke particularly. So we'll take a look at that code as well. Okay. So what's the next thing? The finding that passes every check and is still wrong. So this is an example. What is the issue? It passes the record, every type is correct, passes the validation, every constraint satisfied. But what is the issue? The diff is 35 lines long. There is no line 412 actually. So it tells you here, it tells us that, at line 412, whereas the diff is actually just 35 lines. So this should be something that we should be able to catch. That has also been implemented in the code. So the next thing, so check its homework against the diff, right? So basically what this check does, there is no model in this code. It is a diff passer and a set lookup. The part of your AI feature that describes whether to trust the model is ordinary Java. So what does it do here? It takes the finding that the model has returned, and then it checks it against the diff to be sure if the model's response is actually accurate. So that's what this method actually does. Okay. The model was confident, the diff disagreed. So it will definitely catch it as long as the model doesn't return, as long as the model's response does not tally with the diff data that it reviewed or was provided to it, that code will catch it. What's the next thing? Type safe is doing 3 jobs in this title. So first one is the shape, record plus the enum, wrong fields. What are the catches? Wrong fields, invented severities, unpassed replies. Then domain rules, bin validation, blank titles, confidence of 4.7, line number 0. Then the reality, your diff passer, which is actually the source of truth. Confident findings about code that does not exist. Only the first one is free, right? Only the first one is free. The other 2 are your job, and they are the ones that make it shippable. Yep. So these other 2, we have to implement them. We have to specify those validations, and we have to ensure that whatever implement or whatever checks that we are trying to enforce are properly done, so that we are able to verify the response of the AI and be sure that it gives us accurate response according to the data that's been provided. So that responsibility is left on us as the programmer to implement. Okay, a diff is a keyhole. Is this field ever written from another thread? It's not answerable from 30 added lines. So let the model go and look. So basically, there's a tool functionality that's been provided that enables the agent or the model itself to be able to make a call to the application and carry out some checks itself. So it basically searches, it will basically search the diff and check if the field is actually written from another thread and all that. So just some tool that enables the model to, do some checks on its own on the data that's been provided. So type does not mean trusted. Like I said, I've gone over this. The agent can the model can return, a typed response as you've defined, but it doesn't necessarily mean that you should trust the answer blindly. You still have to do your own checks to ensure that whatever is being returned is returned just the way you expect it and contains the correct information that's required. Fine, but how do you test anyway? So back to testing. Let's see how far this goes. I think we were able to run a test for up to this point. So let's run this test and let's validate the response to see what happens. So basically, the test will be run against the against the incorrect diff. But then after that, I'll run a test against a clean diff that is correct, and let's see what the model's response will be. Okay. So let's validate. Let's run the validation command. Okay. So we are running the same request, asking the model to review the diff, but this time specifying that it should return the response in a particular structure. And also, we are going to validate it as well. So let's see what the response here is. The new transfer flow introduces an in-memory in-flight cache and a direct account load query. As written, it has critical concurrency issues, this. Yep, and then we validated it. So actually, the validation has been executed on the response that the agent provided. If peradventure anything the agent said here was wrong, it will throw an error. So basically, what this is telling us is that all the things that the agent pointed out here, the in-flight cache uses non-thread safe hash map, the blocker, non-atomic in-flight dedupe can double debit under race. All these things are actually at the correct lines that the agent pointed them. So this line 17. Let's look at the diff line 17. Yep, in-flight at line, where is it? In-flight at line 17 is correct. Line 31. This line 31. Okay. Next one is line 35. Yep. Line 35, what was it about? Insufficient funds check is incorrect. Yeah, and that's correct. If from balance dot equals big decimal 0. So yeah, this is incorrect. Yep, you can see that. So yeah, I think the code is working as expected. Line 46, that's where the SQL injection is. Yep, exactly. Line 46, SQL injection, properly caught. Okay, so let's go to the next test. Yeah, so okay, we've done that with the incorrect diff. How about we try? Let's test this with an actual clean data. So let's run only this one. Copy. Let's see. Let's see if the model is going to find any issue with this diff. So just so that you know what we are looking at, this is the diff we are looking at, right? This is the diff we're looking at. So fingers crossed. Okay. Okay, so we can see minor, not really an issue. Verdict. So you can see that the model came back saying, okay, I saw something, but it's not really an issue, nothing big there. And yeah, that's fine. So the code basically works. I think everything that's been demonstrated here works properly. Like I said, one other thing that can be very useful is if you do not have an API key, you can try running this in replay mode. So what when you set the replay flag equals to 1, what is going to happen is it will return to you a cage response. So you know what? Let me do something so that we are sure that okay, so here's what I'm going to do. I'm going to set the, I'm not going to provide an API key so that hopefully it doesn't work. Sorry, guys. You know what? Let me just run the code. Let me just run that line like that. So what we expect here to happen is that it just returns a response that has been recorded. So let's see, where's the recorded data? Yep, so this is the recorded data. So you can see, let's look at this. So I'm running this in replay mode, right? So what did we get here? We said we returned this adds a money plus method that guides against this. So you can see it here. So now it's not making a call to the agent, you know. So what happens here is simply, let me explain this so you understand what's going on here. Where is it? Okay. Yes. So basically what is happening here is everything that has to do with communicating with the AI is taken out. So every other thing works, the validation, you know, the checks, the typing, all that works. But just that now we are not actually making a call to the model, rather. So if you don't have an API key, it's not really a bother. Just add the replay flag to any of the commands you want to execute. So let me run one last one. And then, let's see. So let's run for validated. Yeah. Okay, requested changes. So let's compare this information with what we have saved here. Okay, let's see. This change adds a transfer path to payment service. This change adds a transfer path to payment service. Introduce SQL injection in load account, compares concurrency. Yep, you can see. So we are returning some response that we've already recorded already. So you see that the code still works without a live AI. But let me run it with let me make the call directly to the model. And let's be sure that both of them are not returning the same thing. Or I'm not whitewashing you guys. Let's see. Okay. So there is making the call. Let's see what the model says. Okay. So the reason why the record looks the same is because anytime you make a call to the model at least once, it records that response just in case the next time you don't have access to the model. So that's really what happens. So if you connect to a model and make a call, at least once, it will record that, it will store that here. And then any other time you don't have access to a model or let's say network or something, it will just return that previously stored response. Okay, guys, so back to the summary of this. So I've shown you guys how to test. Most of it does not need a model at all. We know that deterministic runs in CI, it's free, non-deterministic tagged opt-in, right? You can unit test your distrust as well. So there are unit tests in the code that has been provided. I implore you guys to have fun with those. You can extend the test, verify every method or anything you want to verify as well. So this is a contract test, binds to the record, satisfies the constraints, finds the planted injection, So lots of tests to have fun with. Then live review. If you're reviewing from with a live key, what it does. And then unified diff test. Yep. So I believe this is the end of this demo. I hope you guys had a good time with this. Also, just so I'm sure people will have lots and lots and lots and lots of questions. So if you take a look at the inside AI code presentation, you can see there's a section called likely questions. So anything you want to know, why SpringAI instead of OpenAI SDK directly? I believe we cannot answer that, provides us an abstraction, and that's very useful if you want to, talk with other models and not just tied to a particular model. So definitely SpringAI. Is this API's real structured output or just prompting? I believe you guys saw that already. What if the model returns invalid JSON? It will throw an error, definitely. Can I swap to OpenAI or run locally on Ollama? Definitely, yes. That's the benefit of using the SpringAI library. What does a review cost? Estimates. Well, I've not measured that, but looking at the code, I don't think the tokens are so big. The token should not be much, so it should cost you very little. How long does a review take? You saw that roughly between 10 to 15 seconds. What is the false positive rate? Not measured. Why not just use SonarQube, Spotbox? So anything I could have thought, anything I could have thought of, I kind of provided the answers here. Okay, guys. So this ends this presentation, and I hope you enjoyed what you saw. Thank you very much. Any questions?
Thank you. Thank you so much, Mr. Oddy.
Any questions? Any specific request to run anything? I can do that again.
Yeah, thank you so much for that wonderful presentation, Oddy. Well done. We really appreciate. I think Mr. Jonathan and Blight has their hands up. Jonathan, you can go ahead.
Yeah, thank you, Oddy Bassey, for the presentation. I really learned a lot, but I have a question. So my question is around, can we, if you deploy this service or code reviewer to Maven repository or run locally, then have it on M2, can we add the dependency to another Spring Boot service? And maybe when we build the application, it helps us to review any bug or static issues with the code.
Definitely. I think you said it already. So the right thing would be to build the application like a dependency first of all, then package it and put it on any of those repositories, and anybody who would want to use it can definitely add it to their to their POM or to their Gradle this thing, and pull the library. So depending on how you write that library or how this is written, you can definitely, maybe let's say you can add some annotations on your code classes or something, and this will just, whenever you're running a build and all, this can also be executed behind the scenes during your build, and definitely you will get automated reviews about your code. So it all depends on whoever builds the library. But if it's built like a library and certain things are set in place, you can use it in any of your Java code.
Okay, thank you very much.
Sure. Someone else, Bright.
Yeah.
Can you hear me?
Yeah, I can hear you.
Yeah, thank you very much, Oddy. Yeah, thank you. It was quite a powerful one. Yeah, so my question is not like deeply on code analysis, but on the payment side of things, since we're actually talking about payments reviews.
Okay.
So I just want to get some clarity on this. Now, in payment, there are a lot of integrations that go on every day in the
Yeah.
financial sector. So it's either you are integrating floater wave or you're integrating interswitch or other, foreign payment gateways. Now, if you check, the time for integration, it actually, takes long to, complete an integration, to, test it out and to move it to production. It takes a while, roughly 2 weeks if you are very, very fast or something. So I'm not thinking, is it possible, to deploy an AI into this, something that, okay, integrations don't have to be manual again. You don't need to write any code to integrate, a payment gateway or something. Like, can AI actually take care of these, map the whole values, and how can someone go about something like this?
Okay, so that's a very beautiful question. I like that because that's actually something I'm actually thinking about building. So yes, it can be done, but it's more extensive than what you see here. I believe if I wanted to build that, what I would basically do is, first of all, the organization should set up an agent on their infrastructure. So it just depends on how you want to build it. So if I wanted to build something like that, I'll build a tool that is, I'll build an AI that acts as an agent. I'll deploy the agent on in the organization's infrastructure. Then the agent should definitely have access to all the code bases of that organization. So let's say particularly the application that you would like to have multiple integrations done on. Now, as you know, the things that are relevant to integrations is what application are you integrating on, and what is the documentation? What is the documentation for the application you want to integrate with, and what are the resources that you require to reach that application you want to integrate with. So what I mean by resources could be the base URLs, the API keys, depending on how that vendor builds that. But I would believe the documentation would give you more information as to all that. So I believe, and I don't know if you use agents a lot, but as you would know, AI works with context. So the most important thing is your context. Does your context contain enough information that would enable that agent integrate that code? Because what you're basically asking me is just the same thing as you, copying a part of your code, going to ChatGPT or something, giving it and telling it, oh, you know what, help me complete this code, do this, do that. It gives you the code, but the question is now you want it done on an environment somewhere with some other system. So I believe if the agent has access to your repository or your code base or the application particularly you want to integrate something else in, has access to the documentation of the third-party system you're integrating with, also has the resources, the agent can write your code and write it and possibly also test it. Not possibly, definitely test it, depending on the kind of capabilities it has. So I'll just give you an example of what I have in mind for that kind of a thing. So initially, what I wanted to build is an agent that, when all these companies, write code and deploy their code, sometimes some developers can make errors, silly errors, and by the time the code gets to production, the system begins to fail. And imagine it's a critical system like payment systems, and at the time it fails, millions of transaction requests are being processed. This thing could take literally hours, and the organization can lose money. So instead, build an agent that takes a look at, let's say, deployment logs and all that, and deployment logs and running logs by the or log telemetry, as they would call it. By the time, let's say, errors are being thrown because of certain events that's happening, like let's say payment request and all, those errors not only go to your logging systems, but also you pass them to the agent. The agent look at the log, look at the lines, see what the issues are, goes access the repository, makes the fix on the code. After making the fix on the code, commit, push, maybe you can also have a different sub agent that acts as a reviewer to just verify a second time. So verify the PR created by this other agent, merge that. Once that is merged, the other part of the pipeline triggers. And once it triggers, the error is fixed, the application gets back into running state, and the company goes on to make their money. So this, the question you asked, that's a wonderful problem to solve in the industry, which some organizations, or not some, a lot of organizations currently face that issue. So if maybe somebody comes to build that, you can even sell that to a lot of industries, to a lot of companies. But as you would know, that would also reduce the relevance of the number of developers they have. I'm sure you don't want your friends to lose their job. So it just has to be a balance. Yeah, so yes, your question, that can definitely be built. If you have the time, you can try it as well.
Thank you so much, Oddy. No,
Yeah.
Bright, you can go ahead if you still have a follow-up question.
I'm done. Thank you very much.
All right. Yeah, Oddy, talking about relevance, Stephanie is asking on the chat. I will start with the second question because it's more in line with what you just finished talking about. So I was thinking that with what we have seen so far, AI generates and reviews code. But what part of software engineering do you think will become more valuable for humans as AI gets better every day? And what part do you think will be largely automated? That's the first time. Maybe when you're done, we'll move to the second
The
question.
first question is, what part of software engineering will do it?
She's asking that given that AI now generates and also reviews code, what part of software engineering do you think that humans will be relevant and will be more valuable as AI gets better every day? And also, what part do you think will be largely automated?
Okay, so that's a beautiful question. Already, I think that is playing out. The question she asked is already playing out in the industry. And first of all, the part that I think, even right now, humans are not exactly very relevant is coding. I will tell you for free, there are a lot of these frontier models, Claude, GPT, Grok, the likes. A lot of them code better than many mid-level devs. In fact, let me not say many mid-level devs. They code better than me. So let me start with myself. Claude codes better than me. There are lots of, I'm a Java developer, right? I write Java code. I've been writing Java code for over 7 years. Sometimes I use Claude to code and I see some kind of standards and this thing it enforces. And I know that there's no way I would have written this if I had not spent maybe 3 to 4 hours researching standards and all. So when it comes to coding, I think AI has the dominance there. But I think what developers should be moving towards is systems engineering. It will take a long time, to have AI to be good systems engineers. And I say this because I know some people will argue, yes, there are agents, there are this, there are that. But you see, the thing we need to also remember is, as much as a software is not just only the application in itself, it's also the application as well as everything that comes with that system in production. Sometimes, as before, when we build systems, we'll be so happy, oh my God, I built the next big thing and all. Put that thing in, just deploy that thing and allow even 100 users, 1,000 users use it. You realize that it's a total different scenario entirely. The playing ground changes. So because of those variables of real world use, it may be difficult to get AI to be very good systems engineers currently. AI is advancing, right? So currently, I believe we have a stronger advantage being systems engineers. And when I say systems engineers, I'm not saying that we are not going to code. We are going to code, but the idea is that you engineer how the systems are built. If for a lot of us that uses AI, and I'm sure almost everybody uses AI, if we are going to be honest, almost everybody is currently using AI to code. So if you know how to use AI and you have good knowledge about how to build systems, you know what the problems can be if this system gets into into production based on the business domain or the business criteria of that system, you should be able to engineer the software even better with AI. So I think what we can move towards is systems engineering and not really focus so much on coding. Because if you would even ask me as a developer, I would rather pay someone who uses AI to code, because first of all, it saves me more money, it saves me time, I ship quickly, than have somebody code from scratch. And that's not to say that using AI doesn't come with its own challenges, but for me, it's us striking a balance, between the trade-off. So once we can strike, so the balance is now where you now see companies not looking for front-end developer and this and that anymore. Instead, you now see them put out titles like systems engineer, AI engineer, everything around the engineering of software. So that's what I would recommend based on what I'm now seeing in the industry. You can learn to code, but just understand the foundations and the basics of it. Put more effort in knowing how to use AI, understand how to build systems. In fact, I can bet you that you may likely find a better systems engineer very soon in the next 5 years that doesn't even know how to code as much as a lot of us learned, all these years. And that's the reality of it. It's just like now, you see all of us, we're using IDEs. There were people who, back in the days, in the early 2090s, there were people who would write code in text files, knew how to set up the compilers, knew how to set up the, all those things. But today, who does that? Nobody. I don't have that. Why am I going to go and sit down and use Notepad and be doing all that? Nobody does that. I just go pick up my ID and do my thing, and I don't even know how the Java thing even works behind the scenes. Although I know, it's good to know, but you get the point. So in the next 5 years, you will see systems engineers that if you open the code and tell them, look at it, they will run. But yeah, that's just how technology works, right? As we make things become easier, a lot of detail becomes abstracted and it may not necessarily be relevant anymore. Yeah, so move away from coding, move towards systems engineering. That's just basically what I'm trying to say.
Thank you so much, Oddy.
So,
but what do you think about cloud computing? Do you think AI is taking over that space there anytime soon?
not at all. How does AI take over? So, except, okay, let me give you the perspective. I'm thinking about that. How will AI take away cloud computing? I don't really see how it's going to do that, because at the end of the day, AI depends on cloud computing as well. Your ability, the reason why we are able to, to make use of ChatGPT as much as we do, knowing very well that 1 billion other people in the world are also using it, it's also because of, the cloud and all. So will it take that away? Definitely not. If not for anything, it adds more complexity and problems, which we will now need to solve as regards to cloud computing. And I'll give you a typical example. There are new cybersecurity domains that are coming up now because of AI. I don't really know the names, but I'm sure maybe some of you that work with certain kinds of companies will know the names of those roles. So you now see domains like DevSecOps. There are lots of research around there, lots of research in cybersecurity, all because of what? Because of AI. Does AI really go there to replace anything? Not necessarily, but because of the demands of this new technology, it also places relevant on other domains as well. So as all of us are, because I'm sure a lot of us are now saying, I want this AI to be faster. I want it to be quicker. I want it to give me response, more quicker. All that depends on something, and it depends on the infrastructure part of AI, which is largely cloud computing and the likes. So will it really replace that? Not really. Will it replace roles relevant in that domain? Also, definitely not. If for anything, it will place relevance on certain kinds of expertise. I was telling somebody the other day that there are certain roles that will not be too relevant. In fact, we'll get to a point in the world where companies will begin to look for domain experts, because AI will be able to do every regular thing. AI will be able to do most things, but there will be something that AI really cannot do. You know, when we are building all these AI to do this, to do that, who builds the AI? Who fixes the AI? Right now, AI fixes AI, but at the same time, you also need a little bit of human in the loop to do all that, right? So there are just some areas that AI will definitely not replace, because if it succeeds to completely replace those domains, then there will be, if you ask me, I believe that there'll be some issues in the world where all those movies where we used to watch about AI taking over the world, that can be possible. Because imagine AI taking over cloud. Imagine AI taking over security. You already know what that means. A lot of systems will be broken into, banking systems, medical systems, you know. And because we definitely don't want AI to do that, we as humans will stand guard and, you know, build the necessary guardrails to prevent it from doing that. So no, cloud computing is not going anywhere. It will keep staying.
Thank you so much, Oddy. One more question from Stephanie. She's asking that she would like to know how we can handle costs when running AI-powered code reviews at scale.
That's a good question. It cuts across everything that uses AI, whether it's even code reviews and all. That's a major problem in the industry now. How we can handle costs. The truth is, the bigger the more the information you want to process with AI, the more the cost. I don't think there's really the more the cost, right? The more the information, the more the cost. Maybe the only way we can reduce cost a little bit is, let's say we have something like a RAG system set up within the organization, and instead of making a lot of requests to all these frontier models and all, instead of making all that requests, you just go back to the RAG system and the model can go back to that system, get some augmented information, and then only make requests to the frontier models where relevant, right? That can work. And by RAG, I mean retrieval augmented generation. It's a way of combining an LLM with real-time info, allowing an LLM to have access to real-time information. And sometimes this can even be sitting in-house within the organization. It can be set up in-house within the organization. So, but as long as you want to be making calls to these frontier models, you want the models to have context about all your information, depending on the size of that information, you definitely have to pay for it. Except maybe the cost of these calls is reduced by the companies that own these models. But aside that, the best you can do if you want to reduce costs is just don't make the request, because as long as you make that request, it will be more expensive. Or have a rack system sitting in-house, so you don't always have to make those calls. Your data is readily available for the AI to have access to. That's what I think anyway.
Okay. Really, this has been an interesting section, and I know that if we keep on going, there'll be more questions. You can look into the chat, but I think Blight is asking, do you think AI will be like the next NFTs?
I don't think so. I don't think so. I don't think it will die down. The reason is, I think you can look at history and you can see how you can look at certain patterns in history. There are some technologies that are not just that will not just come and have a hype and die down. Some technologies will revolutionize the world, and I think AI is one of them. Just like when computers came, computers changed everything in the world. Right now, looking at AI, you already know that AI has influenced every part of life, every part of all domains and professions you can think of: medicine, medicine, science, law, whatever you can think of. So it's not going to be a hype that will come and die down. I think it's here to stay. The question is, how far will it go? That's the question, because now they're talking about humanoids. They're talking about humanoids. Some people are even building, some people are going as far as building, going as far as even building humanoids that are companions, sex companions and all. So AI is really going far, just the way computer has now become a daily part of our lives. And when I say computer, it doesn't just necessarily mean our laptops. Even your devices, your computing devices, they're all computers. Your mobile, your digital watches, all those things are computing devices. So you've seen how those things have really taken a place in our lives. I think that's what AI is coming to do. So it will not be a hype. It's just, we just hope that certain things are done so that it does not cause a more negative effects than positives. Because right now, when you even look at domains like education and children's ability to learn, you see, and this is common with even us on the call. You see that most people now just rely so much on AI. Most people are not thinking, they will just, any problem they come across, they just jump to that. It's become a lifestyle. So I hope that it gets better than it gets worse with AI. But it's definitely not a hype that will die. It's here to stay. Do you think uploaded intelligence will be a thing? I think maybe we should end it here. If not, the question keeps going.
Okay, let's just take one more question from Anas, and then please, any other person that have a question, you can join us on our WhatsApp group chat. Drop your questions there, and Mr. Oddy will be happy to answer them. Thank you. Anas, you can go ahead.
Hello, good evening.
Yeah, good evening.
So, Mr. Oddy, LLMs can generate and review codes in many programming languages. So, what makes Java a good choice for building an AI-powered code reviewer with SpringAI, just as in your topic? Is Java actually giving us an advantage here, or would languages like Python be a better fit for working with LLMs? I would like to hear your thoughts.
Okay, so I think that's a simple one. Now it depends on what your trade-offs, what trade-offs you want to make. But here's it. Why, for me to answer this simply, why Java would be the best is those qualities of Java that make it different from other languages. So what are those qualities that make Java quite unique and stand out from other languages? First of all, we know that Java is highly strongly typed. It is object-oriented, highly object-oriented. What does this necessarily mean? What advantages do these qualities bring? We know that object-oriented languages, gives us the ability to model real-world systems better. It gives us a certain level of security, because you know that this code is not like, no offense with JavaScript developers, but when you build systems with Java, you know that as long as you build it the way it's meant to be built, if it runs here, if you run that code 1 million times, it will behave that same way 1 million times. It doesn't change. But somebody writes a bad code in JavaScript, you run it on Chrome, it behaves like Tom. You run it on Firefox, it behaves like Jerry, right? So you don't want that happening on your critical systems, definitely.
Oh.
So those are the advantage. Another thing is data typing. Typing is very important. As much as a lot of people want to write code in a very flexible manner, flexibility gives room for more issues, more problem. But with strict typing, you know for sure that, okay, you control the environment, you control the behavior. Nothing will happen. Nothing will just happen without you knowing, right? So if you ask me, the innate qualities of Java are really what makes it even make it a good fit for this kind of a thing. I know some people will argue Python, why not use Python? Yes, definitely use Python. Python is the AI native language, but then in a production environment, Python is like 3 times, or not even 3 times, 5 times slower than Java, right? And to be very honest with you, to be frank with you, I don't think it's a it's an argument against languages. It's more of an argument of where is it best to use this against this. So if you ask me if I wanted to even build such stuff with Java, I would say make Java the core engine, still use Python, because there are multiple ways. If you look at all these tools that a lot of us use, when you really go to the code base of these tools, you find that it's not just built with one language. Many things are being used, scripting languages, Python, and the likes. So it's not a language against language. It's just knowing how to combine them and use them where it's best appropriate. If you want scripting, I will definitely not tell you use Java to write a scripting language. If you want a command line tool that does CI evaluations and all that, definitely not Java. Python is more suited for that kind of thing. But when you want to go to enterprise level systems, integrate AI with this and that, Java is a good fit. Performance, type safety, assurance. You can go to bed knowing that code is not dancing lullaby. If you write it with some other language, maybe someone makes a request to debit 1 naira, receives a response and it's debited 3 million naira. But yeah, that's just a joke, but you get the response.
Yeah. You've answered my question. One more thing. LLMs can sometimes produce code that looks like, correct, but logically wrong or does not compile. How can we design like a Java-based AI code reviewer so that it doesn't just trust the LLM, but actually verifies whether the AI's recommendations are correct?
So yeah, I think, so the demo we had here actually showed a scenario like that, right? You define your types constrain the LLM to provide the response in the way you want it. But again, if you also want to verify the content of that response, you have to implement that verification yourself. You're definitely not going to leave it to AI. Just to give you the answer on top level, not to dive in, because then we'll start looking at what sort of implementations. But so my simple answer to that is, if you want to verify that, you definitely have to implement the verification yourself, so that by the time the data you're getting from the AI comes, you are able to verify that or not. That's what I think. That's how I would do it.
Thank you so very much.
Thank you.
This was an amazing section. Everybody here can attest to that. Thank you so much for taking out time to share with us from the wealth of knowledge that you have. Thank you.
You guys are knowledgeable too. Thank you very much.
Some other time. Thank you so much. And also, this is to remind everyone on the call, we'll be having our anniversary event, 1 year anniversary on Saturday, 8 p.m. Do well to join us. Please, the links to our social media is on the channel, on the chats. Kindly join us on WhatsApp, LinkedIn, and YouTube, where we also be posting this section so that you can follow up in case you missed anything. Thank you so much, everyone, for joining today's call. You all are the real MVPs. And until next time, you all have an amazing night. Thank you.
Thank you very much. Bye, guys.
Bye. Thank you.
Yeah, bye. Thank you.